Hey there, welcome to Introduction to Chemistry 1.1. In this video, we're going to be looking at the properties of chemical substances. So let's get into it. Alright, so the first thing we're going to do here is look at this hierarchy over here, in which matter can be classified by both physical properties and chemical properties. Physical properties are characteristics that can be observed without changing the identity of a substance. For example, if I were to observe the physical properties of CH4 or methane, even after I observe the physical properties, the substance, the chemical composition, remains the same. It's still methane, it's still CH4. On the other hand, chemical properties are defined by the change of a substance to another. So if I were to look at the chemical properties and maybe combust methane, I would produce CO2 and H2O through combustion. And those are new substances, which would make that particular property a chemical property. Alright, so that's the main distinguishment between the two types of properties there. And the best way to look at this is to look at common properties in chemistry and probably classify them as either physical or chemical properties. So let's do that. The first thing we're going to look at here is going to be called density. So let's write that in here, density. And density is defined as the mass per unit volume. So here's the formula up at the top over here. Is D is going to equal M over V, where M refers to mass and V refers to volume. And this is an example of a physical property because both mass and volume can be measured without changing the chemical composition of the substance. In fact, it's pretty easy to measure both of them. You can just literally put a scale to it. So to determine the mass and volume does not require any kind of chemical altercation. So density is going to be a physical property. All right, let's look at the next one here. We're going to look at melting and boiling points, melting/boiling point, right? And as you can tell, this is an example of a physical property. Why is it a physical property? Well, melting and boiling point refers to the temperature. It refers to the temperature at which there is a phase change. So in the instance of melting, it's going to go from a solid to a liquid. And in the instance of boiling, it's going to go from a liquid to a gas. And it refers to a specific temperature at which this happens. Now, in this instance, so say we go from H2O as a solid to H2O as a liquid. Right? And there is a phase change, absolutely, but the chemical composition of the compound H2O, this remains constant. There's no altercation to the chemical composition. So for that reason, this is an example of physical change, and it's a physical property. All phase changes are physical changes, and for those reasons, these properties here are physical properties. All right, and this refers to the temperature, just to keep that in mind. The next thing we're going to look at probably is going to be maybe color and shape. Right? These are a bit more of the obvious ones. Color and shape is some of the first things that you see when you look at something. And this is an example of a physical property. Why? Because obviously it doesn't require any chemical altercation because it's the first thing you see when you look at something. So that's pretty self-explanatory there. All right. And then we're going to add a few more. We're going to add mass as a physical property. And let's add maybe dimensions. Let's add dimensions. All right. So mass refers to the weight of something, while dimensions refers to the, it can refer to the length, to the width, to the height. And these things are all physical properties because to measure these, as I mentioned earlier, you can put it to some kind of device. You can use a scale and measure these quantities. So for that reason, it doesn't require any chemical altercation of any sort. So these are physical properties. So now let's look at some chemical properties that are pretty common. And one of the main ones you'll see is flammability or flammability. Flammability. And what this is a susceptibility of a substance to catch fire or to undergo to catch fire or to have flames. And this is a chemical property because fire often results in the production of a new substance. So it's going to be a chemical property by definition. A more common one is rusting. And this is one that you will see particularly in metals. And when a metal rusts, it actually produces a new substance. It produces a compound between oxygen and that particular metal. So since it forms a new substance, that is an example of a chemical change by definition, and that's going to be a chemical property. Okay? And let's look at one more chemical property. Maybe we could look at something like reactivity. Reactivity. And reactivity refers to how reactive a particular substance is chemically. And to determine reactivity, we need to react a substance with another substance, which would produce a brand new substance. And for that reason, this is a chemical change, because to test reactivity, it produces a new substance. So that's why reactivity here is going to be a chemical property. All right, so looking back to this hierarchy over here, we see there's an extra extension here. And we see that physical properties branch off into quantitative and qualitative physical properties. Okay, so what do those terms mean? Quantitative physical properties can be measured, and they can be assigned numerical values. Something like 1, 2, 3, maybe 35 grams. Something like these kind of things are quantitative properties. And the best way to remember this is to look at the first part of the term here, quan, and that could stand for quantity, which is, you know, a certain amount of something. So the key here is to recognize that quantitative properties typically have numerical values, as opposed to qualitative properties, which have values that can be observed. Sorry, they don't have values. They're just observable traits that can be seen with the 5 senses, right? With the 5 senses. Okay, and these properties are something that you would see immediately. So let's try and classify each of these following here as either quantitative or qualitative properties. The first one here is going to be density. Density is an example of a quantitative property. So let's do, maybe we can do Qn for quantitative. A quantitative property. Why? Because its formula, you know, mass and volume, they're both numerical values, and for that reason it's going to produce a numerical value. So it's going to be a quantitative property. Melting and boiling point, if you remember, is a particular temperature, and temperature is often represented by a numerical value, whether it be in kelvins or Celsius. So that's also going to be an example of a quantitative property. However, color and shape, and by shape I'm just referring to the general way something looks, and these things are both examples of qualitative properties. Why? Because this is something that you observe with your sight, right? And that's an example of your 5 senses, and that's going to be a qualitative property. There's no numerical value attached to color, unless you want to look at it from an RGB perspective, but for our purposes, you know, there are no numerical values attached with that. So we're going to look at QL here for qualitative. And finally, the last one here is going to be mass and dimensions. And then again, these have numerical values. Mass can be something like 15 kilograms, so it's numerical. And you can look at dimensions as 1 by 1 by 1, which is numerical as well. So this is going to be a quantitative property. All right, that sounds good.
Another thing we're going to look at are intensive and extensive properties. So let me write that down here. Let's zoom in a little bit. We're going to have intensive, and extensive properties. So let me give you the definition. So intensive properties are properties that are independent of a sample's size, independent of size, or a substance's size. All right. While extensive properties are dependent on size. They vary depending on how big or how small or how long or how tall something is. Okay, so the obvious way to remember this could be, oh, you look at independent, so you get in here, and you look at intensive. So the prefixes there are the same. So that's a good way to remember intensive properties are independent of size. All right, so let's do something. Let's look through each of these examples here and classify the properties as either intensive or extensive. And if it is, let me just use some highlighter here. If it is intensive, we will highlight it in yellow. And if it is extensive, we won't highlight it. Okay? So a property like density. Density, as we mentioned earlier, is mass per unit volume. And this is a formula for density up here. Since it factors in mass per unit volume in its formula, it's a constant value. The density of a substance remains pretty much constant no matter how much of the substance you have, because it factors it in for the amount of a particular substance. So for that reason, density is considered as an intensive property. All right. Same thing with melting and boiling point. As mentioned earlier, melting and boiling point refer to specific temperatures in which a phase change occurs, and this is measured by a particular sample. So the mass part of it is already factored in, and this is a constant value between substances. It doesn't matter how much substance you have, this value remains constant. So you're going to have melting and boiling point here. And now we have our first example of an extensive property. And let me just get a different color to highlight that. An extensive property. And as we mentioned, extensive properties are dependent on size. Sorry, we have mass. So mass is something that is extensive because the mass of a substance is directly proportionate to its size, right? Something that's bigger is going to weigh more. So you're going to have mass here, and you're going to have dimensions as well, because maybe your length or your width or your height, these things are all dependent on your dimensions, right? So that's going to be dependent on the size. And I seem to have skipped one by accident, so we're going to go back to that, and it's going to be color. Color, if you can just think about it, is independent of size. Why? Because if I look at an apple, it's still red, but if I were to look at 1,000 apples, the apples are still red. So it doesn't matter how many apples you have, the apple's still going to be red. So color is an intensive property. Okay, that is all for this video. In this video, we looked at the properties of chemical substances. We looked at physical and chemical properties. We looked at quantitative and qualitative physical properties, and we looked at intensive and extensive properties. Hopefully you learned something new. Consider liking or subscribing to the channel. Thank you.